Today, we delve into the revolutionary concept of space elevators, an audacious vision poised to transform space exploration. The idea revolves around a tether extending from Earth's surface into space, held taut by a counterweight beyond geostationary orbit. This megastructure, possibly made from advanced materials like carbon nanotubes, would enable climbers to ascend and descend between Earth and space, powered sustainably by electricity. The potential benefits are immense, drastically reducing the cost of space travel, from satellite deployment to scientific missions, and even opening avenues for space tourism. However, challenges loom large, such as developing materials strong enough for the tether and ensuring structural stability amidst orbital debris and environmental factors. Despite these hurdles, ongoing research and technological advancements offer hope that one day, the space elevator could revolutionize our access to space, ushering in a new era of exploration and discovery. Tyson 2 bits, a massive gas giant larger than Jupiter, stands out in the cosmos not for its beauty but its eerie darkness. Unlike typical planets bathed in starlight, Tyson 2 bits absorbs light so efficiently that it reflects less than charcoal. Its atmosphere, searing hot like molten lava, possibly emits a faint red glow, adding to its ominous odor. In the 55 Cancri system, amidst four gas giants akin to Jupiter, lies 55 Cancri, a planet of extremes. Orbiting dangerously close to its sun, half of its surface is an ocean of molten lava, perpetually facing its scorching star. The other half is a perpetual abyss of darkness, forever shielded from sunlight, with a narrow twilight zone separating these extremes. HD 189,733, despite its picturesque appearance with swirling blue and white patterns, hides a terrifying secret. These patterns are not benign. They are created by silicate particles in its atmosphere, where it rains glass. Winds on this planet scream at speeds nearing 5,400 miles per hour, turning falling glass into deadly projectiles. In the pulsar system, unnamed for its complexity, 3 exoplanets are slowly disintegrating, orbiting a rapidly spinning pulsar, the remnants of a dead star. These planets face destruction from intense electromagnetic pulses and rapid rotation. Over time, they will be consumed entirely by their erratic host. Kepler 70 bits, a victim of its star's transformation from blue dwarf to red giant, survives as a scorched remnant. Once a gas giant resembling Jupiter, it now endures temperatures surpassing those of our sun's surface. Its fate sealed, it will likely evaporate into oblivion in the cosmic blink of an eye. WASTE 12 bits' tragic existence epitomizes celestial despair. Gravitationally stretched and consumed by its star, this gas giant is unable to escape its fiery fate. Over the next 10 million years, it will be devoured, its once grand form reduced to an insignificant memory. LACY 436 bits defies logic with its icy exterior under scorching temperatures hotter than an oven. Its dense ice, resistant to melting due to immense gravity, perpetually burns without turning to liquid, a paradox of extreme conditions. Venus, Earth's malevolent twin, shrouded in a thick, toxic atmosphere of sulfuric acid clouds, endures surface temperatures hotter than Mercury. Volcanic eruptions ravage its landscape under crushing gravity, making any attempt to penetrate its deadly clouds futile against hurricane-force winds. Ogle 2005 BLG 390 Elb, despite proximity to its red dwarf star, resides in perpetual darkness and cold, with temperatures plummeting near absolute zero. Its dark, icy surface, unmoved by feeble starlight, conceals potential mysteries deep beneath its frigid exterior. Dimidium, tidally locked to its sun, suffers stark contrasts. One side scorched beyond recognition, the other shrouded in perpetual darkness. The violent interplay of extreme temperatures melts iron in its atmosphere, raining molten metal upon its surface, an infernal landscape devoid of hope. Osiris, orbiting dangerously close to its star, endures temperatures that defy comprehension, where oxygen itself fuels unrelenting combustion. Its brief orbit of just 3.5 days on Earth unleashes relentless atmospheric turmoil, perpetually reshaping its scalding surface under the unyielding heat of its sun. These worlds, each a testament to the extremes of our universe, challenge our understanding of planetary existence, offering glimpses into realms where nature's rules are bent and the unimaginable becomes reality. Carati XO3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own insidious way. It's a gas giant, similar in size to Jupiter, yet 20 times denser. This makes the planet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom because you'd be immediately crushed by the density of its atmosphere. Carati 7b presents another infernal landscape. Its day-to-day temperature is over 4,000 degrees, combined with a rocky surface where rocks on the ground bubble and boil, eventually evaporating in the atmosphere where they cool down and fall back in a brimstone rain. The saddest thing about Carati 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. We're accustomed to thinking that asteroids are the only free-floating rocks in space, but objects like OTS 44 make us think twice and shiver. Imagine a planet about 11 times more massive than Jupiter roaming in space without being bound to the orbit of any star. Given its gargantuan size and mass, if OTS 44 collides with any other planet, it would utterly destroy it and continue floating as if nothing happened. Even scarier, scientists are sure there are millions of such rogue planets out there just waiting to be discovered. There's no hard proof of their existence yet, but theoretically, carbon planets have formed somewhere closer to the center of our galaxy. Any oxygen getting into their atmosphere would react with carbon and transform into CO2, forming black toxic clouds on the ground. There would be oceans made of tar, spewing up geysers of methane and crude oil. There would be rains too, but they'd be far from refreshing. Torrents of pure gasoline and hot liquid asphalt would blast the ground and probably burst into flames on impact. It's hard to imagine anything that would survive such conditions. Imagine being in the middle of the ocean, endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you, and you're alone. Even if you try to swim down after several hours, you still wouldn't be able to see the bottom of the ocean. That's a typical water planet for you. I know it sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a closer look at them. An ocean planet consists mainly of water, ice, and perhaps some rocks. Think of Earth's oceans with their horrifying depths like the Mariana Trench. Now, can you guess how much space all the water on Earth takes up? It's 0.025% exactly. Now, imagine a world that's 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. The pressure there would be enormous, reaching up to 20,000 Earth atmospheres. Very crushing indeed. It may sound scary, but it would still be fascinating to learn more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. You don't have to go far to find these water worlds. You can find them even in our solar system, not as planets, of course, but as moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The oceans on these moons can reach up to 30% of their mass, although it's unclear whether these oceans are covered with a thick crust of ice. Nonetheless, we've discovered quite a few fully fledged ocean planets. The conditions in which these planets may exist are very specific. For example, such a planet should be somewhere between 6 to 8 times larger than Earth. If it's smaller, it would have a rocky surface, but if it's bigger, it would turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yes, these planets are very picky about where they can form. We first started exploring these planets back in the 1970s. However, since then, we've only found a couple of them, but they're still very interesting. The first planet is GJ 1214 bits. It was the very first ocean planet that we discovered. Initially, scientists noticed only a small dim dot. This dot turned out to be the red dwarf star G1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't have been concerned about it at all, but back in 2009, they noticed that this star had a single planet. This planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier. However, it had a very, very low density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. That's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite perplexing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, perfectly hiding its composition. But even so, it's probably a water world. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these planets are better than Earth, but we also know thousands of other exoplanets that are just close enough to ours, and the odds are a few of them have at least some form of life. But they're very, very far away. So we have no way to check it out right now. Perhaps down the road, we'll find some cool creatures on many of them. That's it for today. So hey, if you satisfied your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.